So if let's go back to the data. So this is data we are working with. So let's learn how to plot now. If you want to plot, you go to graph and click chart builder. So you go to graph chart builder. Then you select what you want to plot. Is it bar charts? Is it pie charts? What you want? So let me start with bar. So in bar chart, we have different types. We have the simple bar chart. We have the multiple bar chart. We have the what's the last one? Component bar chart, right? So let's start with the simple bar chart. When you look at what you do, you click it and move to this place. You click and move. So what do you want to plot? I want to plot the grade. So I'll click grade and move to this place. Then look at this. It will ask you, what do you want to use? You want to use count. Count, that's what you want to use, count. So I'll click OK. So that's it. It means it will count the number of A's. It will count the number of B's. It will count the number of C's. So let me start again. You have a data and you are asked, can I get a bar chart from this? So that we know the number of A's, number of B's. So you go to graph. Remember, we also got this bar chart using frequency. If you remember, we got this bar chart also using frequency. It's possible to get it through this place. Sorry. We also got it using this. Awesome, but you can also get it using graph. So you go to graph, you go to chart builder. Let me reset it. I want a simple bar chart, so I will click this and move to this. I want for grade, so you move it and place it in x-axis. Then look at it, count. Count means just count it. That's all, nothing else. Okay. So it is, if you watch it, the plot are the same. Like I've taught you, if you want to change the color, because I know that Lois will not like this color. So if you want to change the color, you double click it. You click on this and come to this place and change the color. So the color you want. If you want the numbers to show at the top, you click this. That means the actual value that this bar is showing. You click this and the number will show. If you want to move this number up, you change it to custom and select where you want to move it. If you want it to come to the topmost, you click this and click apply. If you want to do it yourself, you want to arrange it yourself, you want to move it, you click and move. 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 That if you want to do it yourself. Then when you are done, you close this. Don't go and arrange your plot. This will look like a mad graph. So that's all for bar chart. So let's go back to our chart builder. Remember, if you want to plot, you go to charts. You go to chart builder. Let me reset it. So I can decide to plot a multiple bar chart. A multiple bar chart. I'm talking about the grades of students. The grades of students. But I want to also separate it by gender. Separate it using male and female. Let me start all over. You move your multiple bar charts. Yes, I'm talking about grade of students. But can I create two groups? I've moved the grade here, like the way we did it in simple bar chart. But can I create two groups so that I will know for male and I will know what happened to female? I want to see the number of male and the number for female. So I'll move gender, look at where I'll place it. So this is what I will use to group them. It's still in count. Then I'll click OK. I think that I've been able to. Are you seeing what happened there? Are you seeing what happened there? It means that all the females got A. That means none of the females got B, C, D, E, F. That's what I'm saying here. All the females got A. But you see that the males, they got A, B, C, D, E, F. So this is how to create a multiple bar chart. This is how to create a multiple bar chart. If I double click it, I can change. Let me see if I can change the color. You click the bar. It's not changing. Okay, it's changing. So I can change the color also. So you change the color you want. I can click this bar and change it to any color I want. So your choice. Then if I want the number to show, I'll click the bar here and click this. Numbers are showing. If you want it to go to the top, you click custom and move it to the top. Apply. Then you close. When don't, there's nothing like save in this place. Just close it. Once you close it, to show here. So that's all. So now you can also create a component bar chart. This one is multiple. Component and multiple, they are the same thing. They do the same thing. It's just like creating a group for the chart, but just the way you want it to be arranged. That's all. So I want to create a component bar chart. I will reset it. I will move my component bar chart here. Then the same thing we did. You move your grid to this place. Then for this place, you move your gender. Hope we're seeing that I've been avoiding my y-axis. Why? Because I'm using count. I've been avoiding my y-axis because I'm using what? Count. So I click OK. This is stacked. The same thing. If you don't want, if you want to change anything, you double click it and you change the color. Are you seeing I'm changing the color? If you want to change male, you can click this male here, or you click the male here. So you change the color. So you choose the color you want. If you want the numbers to show, you click this. It's showing. Then look at, so that's all. Let me close. Any questions so far? So go back to my chart builder. Okay, let me stop sharing. Who has left us? We are now 4. Okay, Felicity. Lois, do you understand what I explained now? Unmute yourself, Lois.
I just joined now. The
No,
classes
this one is a new topic. This one is a new topic.
I know, I'm following. It's about bar charts now.
You can
the color I used, I did not use. I don't like that color. I don't like yellow color.
But you understand what I did, right?
Yes, I understand.
So that means, because after this class, I will give you an assignment.
With practice.
So yes, that's why you practice. So after this class, you get your own software. So you do your assignment.
Sir.
So the assignment, I want to plot a chart. So,
okay.
Santos, hope you understood what I explained.
Yes, sir.
Piro, Oga Piro, did you follow? Okay.
Yes, I understood what you said.
Okay, so let's continue. Lois, mute yourself. I know you are seeing a movie. Lois, mute yourself.
Me? I'm not seeing a movie. Oh,
yeah, mute yourself. So let's continue. So let me share my screen again. So we are done with this. So let's plot another graph. So we can decide to use a line graph. So it depends on your choice. Why do we use graph? Graph is for visual representation of your data. That's all. I say graph is what? Visual representation of your data. So we can decide to use line graph. So you click it and drag to this place. That's how we do it. Then what do you want to use as your x-axis? I can try to use grade and click OK. So this is the grade for A, the grade for B, the grade for C, the grade for D, the grade for E, the grade for F. I'm snapping. Jesus. Okay, let's continue. So grade for E, grade for B, grade for C. So both of them do the same thing, just trying to show you a graphical representation of your data. Depends on how you want it. So if you want to edit it, you double click it. You click the line if you want to change the color. Let me see. Okay, I can change the color. So you change the color. So when you want to double click it and change the color. So look at where I'm changing the color of the line. You click and click apply. So when you are done, you close it. If you want the numbers to show, you click the line, you click this. You click the line and you click this. So the numbers are showing. If you want to also edit the number, you click custom and move it to where you want. When you click apply. Okay, it's not moving. So you can move it the way you want. You can drag it. So you close it. So that's it. So let's go back to our chart. So most times when they give me work for data visualization, I ask them what they want and they tell me what they want. So when they tell me what they want, sometimes they may not know the exact chart they want to use. So I will be the one to select. Should I use a bar chart? Should I use a line graph? Should I use pie chart? You'll be the one to select. So let's go to pie chart and see what we have in pie chart. You go to pie chart. Okay, let me see this line graph. So I've moved the second line graph. This second one. We have grades. We move grades. So let me move gender to this place. Okay, it will not work. Remember, our own gender is only in A, so it will not really show us a line because for female, we only have a student that got A, so it's biased. Let me go to my graph. So if I want pie chart, I will go to pie chart. Let me reset it and move this. Then I select my grade to this. Okay, so that's all.
Sir, please, can I ask a question now or later?
You are free. Ask your question. Ask.
That place you always put grade. Is it compulsory that grade must be there?
No, because I'm plotting for grade. The question is plot for grade. So example, if I want to plot for gender, let me try. So that's a good question too. So let me do for gender. So I want to use gender now. So gender will only be for what? Male and female. I see it.
Okay, sir.
But what you put there, if you notice, what I've been putting at the denominator is a categorical variable. In SPSS, they call categorical variables string. They call numbers numeric. Characters string. We'll know that characters are string. They're also called qualitative. Then numbers, they are called quantitative. But you just know that you put a qualitative variable there. Qualitative is for string. Qualitative, quality. Then it's for string. It's same thing as character. It's same thing as alphabet. Then quantitative, quantity is for numeric. It's for numbers. So if you want to edit this chart now, you can double click. So which color do you like, Lloyd? Let me use your color.
Blue.
Okay, it's blue already. So this other one, which color should I use?
You can use red.
Let me change to red.
I
Then
don't,
I'll
I don't
click
need
apply.
green. Nigeria is fucking up.
Lois, we are in the teacher. You are using the word F. You are using that F word.
I'm sorry.
No, that
I'm
this
so
thing is
sorry.
they are recording this thing. 10 years time, your
I'm
children, your 20 years time, your children will see this and they will say, Mommy said fucking up.
I'm sorry. I'm so sorry. Okay, sir.
Okay,
Thank you
you're welcome.
for answering the question. Okay, because
So
I
we
was
are
thinking our agenda is always supposed to be down and then
no.
grade
Depends
will be
on
okay.
the question you are asked.
Okay. Okay, sir.
Okay. So now
Let
let's
me
go back
mute
to chat
myself.
builder. So we have scatter plots. Let me reset. So I click scatter plot. When do we use scatter plot? We can't use it now because of what we have. We have limited data. Scatter plot is where you have X and Y axis. So let me create another data. Let me simulate another data. So let's practice how to simulate data again. Are you seeing my arrow programming? Piru, you are seeing my arrow programming, right?
Yes.
So let's simulate data again now. I want to simulate scores for, let's say, chemistry. Chem 1. Let me just call it chemistry.
Sir, please,
Now,
what is simulate?
no. This one is not part of my course. It's not part of what I'm teaching. But if you want to learn, it's just free knowledge. If you want to learn, you learn. But it's not part of what you are doing. Now, but let me answer your question. Simulate means you want to mimic values. You want to create values from nowhere. You are not using real values. You just want to create values. Instead of you typing it with your hand manually, typing it manually, you may be biased. Because, for example, now, since you like, if you like a particular number, if you like 5, let's say your love is 25 years, you will discover that you'll just be using 25 because what? Your love is 25 years. So you'll be biased. So that's why it's not most times it's not good to write the numbers yourself. So you allow computer to generate value. So simulation means generate values for me. So I want to generate. Hey, I don't talk now. Jesus. Lois, you are the one distracting me. So I want to generate scores, chemistry scores for 1,000 students. So now you ask yourself the distribution to use to simulate the data. Now, for a scores now, the number cannot be negative. The numbers must always be what? Positive. And score can be from 0 to 100. So you now look for a distribution that can give you from 0 to 100. We have different distribution we can use. If I can't use normal distribution, because normal distribution will give me a negative value. I can use exponential, because exponential can give me 0 to infinity. I can use binomial. I can use, so let me use binomial. Or let me use binomial. So if I'm using binomial, it will be a root binom. It will now ask me, let me go back. A root binom. So look at what it will ask me n. N means the number of data I want to simulate. Then the size means the n, like the number that the highest number I can get from the data I want to simulate, the highest number. So this my n here will be 1,000. Then my size will be 100. That means the student cannot score more than 100. Then I will select the probability I want. So I want 1,000 data. The size, no student should score more than 100. Use 0.7 as the probability. I've simulated the data. So if I want to see the data simulated, this is what I will use. So this is what I simulated. I can start to use another distribution for it. So let me use another distribution. Let me use exponential. Always, it must start with arrow. You start with arrow and you write the name of the distribution. So the n, what do you want to use? I want to simulate 1,000 data. Then what's your rate? I can use 4 as my rate, any number you like. Let me see the data I simulated. I don't like this data. Most of them are 0, 0, 0, 0. So exponential is giving us zeros. So let's use a binomial. Let's use binomial. So this is what I simulated. So now I want to save it to. I want to save the data outside the arrow. So I'll go to write CSV. I want to save chemistry data. I want to save chemistry data. What's the name I will use? Use chemistry. This is what I will save it as. Then I will click run. It has saved. Then it will save in my document. I will open it using Word. It has opened. I will copy it and go to Excel and paste it. Then I'll go to data here. I'll go to test to Kulu. I'll go to delimited. I'll click next. You tick this comma because I've done it before. That's why it's a tick. You tick comma. If I remove the comma, this is how it will be before. Then you want a line to form using this comma. You tick comma next. Finish. It has been able to separate it. You can now copy. I'll delete this first row, copy this, and paste to my SPSS. Then I can come to this place and change the name to what? Chemistry. So this is their chemistry score. So let me remove, if I want to remove the decimal point, I'll come to this variable view and change this into 0. For chemistry. So let me go back to why I generated this data. Simulated this data or generate anyone. Because I want to do scatter plots. Okay, let me explain something. Look at what happened here. I click graph. It's asking me all this grammar. Yeah, what's telling me is that I've not defined my variables that I taught you guys in the last class. So remember, you have to define all your variables. It's telling me that we have an unknown. So let me define this variable. So I will change it to scale. So if I change it to scale, this thing will not show me again. So that hope we have learned that. So whenever that thing is telling you, it's telling you that some variables are not defined. So you can ask SPSS to define it manually, or you go and do it yourself. So let's come to scatter plot. I will move this. What do you want to be in my x-axis? I want the student score to be in my x-axis. What should be in my y-axis? Then chemistry should be in my x-axis. Then I can plot. So this is what we mean by scatter plot. When you want to plot x against y, what you've been doing in chemistry, mathematics from secondary school, you want to plot a graph x against y. So this is how it is. It's very simple. So if you want to plot a graph, so that's how you use to plot. So Santos, you can ask your question.
So with the way the graph is now, how are you going to now interpret it?
Okay. Now, most times when they plot graphs, let me delete this. Let me plot it again. Now, this graph is funny because it was simulated data. That's why. But when you plot a graph like this, the essence of this graph now is to show the relationship between student score and chemistry. You are trying to show relationship between two variables. So graph is to show the relationship between what two variables. You can decide to, then you add most time they add a line, the line of best fit. They add line of best fit. You choose linear line. So you add the line of best fit, you close. But it will not give you the arrow. Are you seeing something here? Are you seeing this?
Yes, sir.
Arrow square. What's the arrow square? 0.00.
0.0.
It's trying to tell you that the relationship between these two is very low. So graph is used to know the relationship between two variables. So because we simulated this data, we didn't simulate it so that they will have relationship. But assuming we did it in a way they will have relationship, this arrow square here will be very high. So when it's very high, it's telling us that chemistry score can influence the student's score. So you're just trying to tell us if this variable can influence this other one. Does this variable has any relationship with the other one? So this arrow square that is very low, 0.003, it means that both of them have no relationship. Now, what to mean by if two things have relationship? It means that, example, if both of us are writing the same exam, it means that if Santos scores 90, if Santos scores 90 and I score 80, Santos scores 80, I score 70, it means both of us, we have a strong relationship. Maybe we are copying together, we are writing to the same thing in the exam, or we are copying from each other. But it just means that both of us there is a relationship between both of us in our exam score. But if, let's say, in maths, Santos scores 20, I score 100. In chemistry, Santos score 100, I score 20. If you watch it, there is no relationship between our score. So that's what. So it normally, Lois, why did you say? So normally, plot is used to know the relationship between two variables. So now let me give you a practical example. Lois, do you want to say anything? So let me give you a practical example. Let me show you a graph. Let me open a new data set. So let me create two variables. Number of hours you spend reading, hours you read, and your exam score. So I have two variables, the hours a student reads. Now, Lois, what I'm doing now, when you watch the first video, you understand it. I will send you the link later.
Okay, sir.
So what I'm doing now, this is very simple. So we treated it extensively in the first class. So now let me just generate value myself. So let's say if a student read for 2 hours, let me remove this decimal point. So if I want to remove decimal point, I'll come to this place and change it to 0. So let's say if a student read for 2 hours, the student will score 40 over 100. A student read for 12 hours, that student will score 90. If a student read for 8 hours, that student will score 75. If the student read for 9 hours, the student will score 78. If the student read for 4 hours, the student will score 50. Student read for 5 hours, the student will score 54. Student read for 7 hours, the student will score 71. So let me use this data now. I've tried to do it in a way to have relationship. So let me go to graph. So we want to check if there is any relationship between the number of hours you spend reading and the score you get in a course. Do you know why it's telling me this? I've not defined my variables. So I can decide to say, scan the data yourself. SPSS, just look at the data and just do it for me. Or I go to variable view and define it. Scale. Something is still missing. What's that? Oh, yeah, do it for me. So I go to my line chart. No, scatter plot. We are in scatter plot. So I want to check if the exam score, I'll move it to here, has anything to do with the hours the students spend reading. I seen it. Then if I want to know the relationship, I can double click it and put my line. Where is that line? This is it. I can close it now. Are we seeing our root square? What's our root square now? 0.978. What's the meaning? That it's very close to 1. So it's trying to tell us that there is a strong relationship. I'm trying to interpret now. There is a strong relationship between. Let me explain. Look at this now. Are we seeing that the underscore is not showing here? What is showing is what I wrote in label. So, Lois, when you check the video, you understand better the first video.
Okay, sir.
Anytime you write anything in label, it will overwrite what is here.
Okay.
In this place, you cannot give space. That's why here is exam underscore score. You cannot give space. So, but I don't want this underscore to be showing in my final result. That's why I wrote it in label.
Okay,
so back to my result. So I'm trying to interpret this now. So interpreting this, I would say there's a strong relationship between exam score and the number of hours a student spend reading. The result shows that 97.8% of the variation in exam score can be determined by the number of hours the students spend reading. Let me say it again. There's a positive relationship, or there's a strong relationship, or a strong positive relationship between exam score and the number of hours a student spend reading. Then 97.8% of the variation in exam score can be explained by the number of hours a student spend reading. Very simple. So I've been able to achieve and to show that when I talk about positive relationship, it means as the number of hours you spend reading is increasing, exam score will also increase. If the number of hours you spend reading decreases, exam score will also decrease. So that's the meaning of positive. Then when we talk about negative relationship, it means as one is increasing, like as God is blessed. No, let me not use this example. So negative relationship means as one is increasing, the other one is decreasing. Or as one is decreasing, the other one is increasing. So that's how it is. So like the more you read, the less possibility of you failing the course. That's a negative relationship. So if you don't read more, you will fail more. But if you read more, you fail less. If you watch it, so this is an example of a negative relationship. So in this case, let me interpret again. There is a strong positive relationship between exam score and the number of hours the students spend reading. This means that 97.8% of the variation in exam score can be explained by the number of hours the students spend reading. So very simple. So today we've been able to achieve all this. Histogram, SPSS doesn't really give us good plot for histogram. Okay, the last thing we are going to talk here is box plot, then we'll stop for today. So we know that we are done with data visualization. Box plot. When do we use box plot? What is box plot used for? Box plot is used to test for different things. One is used to test for normality of a data. No. Normality of data sets. It's not too proper to be using the word a data. Data is plural. So box plot is used to test for normality of data or normality of a variable, if the variable is normally distributed or not. So that's what we use one of the things we use box plot to do. We used to know when the data is not normal, it means it is skewed. Then you now ask yourself, is it skewed to the left or is it skewed to the right? Another thing we use a box plot to know is we used to test for outliers. We use box plot to test for outliers. What do we mean by outliers? Outliers are extreme values. For example, now in a class, if let's say we have a class now, Lois scored 20, John scored 22, Santos scored 23, then Charles scores 80. If you watch well, Charles is an outlier. Why is Charles an outlier? Because Charles didn't follow the scores of the other students. His own score is very far. It's an extreme value, very far from the scores of the other students. So that's what we mean by an outlier. If others are getting 80, 90, 100, 80, 90, 100, and a student scores 20, that student is an outlier. Why? That student is far from the center value or far from the scores of the other students. So that's what we mean by outlier. So outlier is an extreme value. So I've tried to mention two uses of box plot. One, to test for normality, and two, to test for outlier. So now if you look at this data now, let's start with this. I don't think there will be an outlier, yeah, but let's check if there's an outlier. So let's try. Graph, I will reset it. So box plot. Click this. Are we together? Remove this. It should not ask you the variable you want to use. So let me start with the number of hours spent reading. I'll move it to here. Wait. I'm going to graph. So let me create a data so that there will be an outlier. Let me create a new variable. So 99, 97, 96, 98, 96, 99, then 20. Can you hear me? Can you all hear me?
Yes, sir. I can hear
Yes,
you.
sir. Yes, sir.
Okay. So I go to graph, chart, box plot. Let me try this. Are we seeing the outlier? Are we seeing the outlier?
Yes, sir. I'm seeing it.
This number 7. So it's trying to tell me that the 7th, I think that should be the 7th variable. Are you seeing it? Number 7
Yes,
is
sir.
an outlier. So if you watch it, look, others we are getting 99, 97, 96. Then that number 7, that maybe that 7 can be lost. Now score 20. Look at, you're an outlier. So that's the essence of. But let me explain this now. I told you it can be used for normality and outlier. So looking at this data, if this midpoint, if it's at the center, it means it's normally distributed. But if it's not at the center, it's not normally distributed. So looking at this, it's not at the center. Look at where center should be. Center should be around here. So now look at what you do is just this box now. Turn it this way. Turn it this way. This box in your mind, turn it this way. If you turn it this way, you will discover that this line is closer to your left than to your right. Move it this way. Just follow my cursor, move it this way. You discover that this line is closer to your left than to your right. So this thing is skewed to the left. It's skewed to the left. It's not normally distributed. Though it's close to normal in a way because it was close to the center line. So this is how to know. So I've used this thing now to test for normality and outlier. So it's not normally distributed, it's skewed to the left. How did I know that it's skewed to the left? In my mind, I turned this way, anti-clockwise. Then after just turn it this way, you know, discover that this center line is closer to your left. It's at your left now, so it's skewed to the left. So this is an outlier. So that's the essence of box plot. Box plot is used to test for outlet. So this is how I did it. I went to graph, chart builder. I went to box plot. I moved this here. Then I click the variable I'm looking for. I moved it to y-axis, not x. Move it to y-axis. Then I click OK. That's all. Box plot. Okay, let me explain something in bar charts. I think that will be the last. There was a day someone gave me a work to do on bar charts, and the person told me that she wants. So let me go back to the other data. She wants what they call error bars. Error bars. So you move your chart. We talk about grade. So we'll be using grade. You can use gender. So she was telling me that she wants error bars. So look at where you click error bars. Are we seeing it? Now they have different ways of calculating it. So yeah, we are using confidence interval for the error bars. Apply. Okay. So this is what we mean by error bars. Now, what's this error? This error bar, I think they use it to test for outliers also. If it's outside, if is that what they use it for? Okay, this one is confidence interval. It's used to tell us the lowest and the highest. This is actual value. This is the highest and the lowest. And in confidence interval, under estimation, we have point estimation and interval estimation. Most times, it's not advisable to report your result as a point estimation. Rather, it's better to report it as an interval estimation. That's why sometimes you see they will tell you that the average revenue of this company is between 70 to 80 million dollars. So what they are trying to do is they're trying to report it using confidence interval. So in this case, now what we use as our error bar as a confidence interval, it tells us the lowest and the highest that we can report. So it tells us that the value of A, the number of students that will score A in that class is between this interval to this interval. Sanders, you can ask your question, then we'll end here.
Okay. Sorry, sir. So I'd like to ask you, how did you get the error bar?
Okay, let me do it again. Go to charts, chart builder, reset, bar charts. Let me use gender now. You click this. Are you seeing display error bars?
Yes, sir.
So you click it. Apply. That's all.
Okay.
Okay.
Sir?
Yes. Yes,
Sir,
Lois.
can you hear me?
Yes,
Okay,
yes.
so now, when you click the display error bars, it was only confidence interval that popped up.
Yes.
Is it that it's only confidence interval that is allowed to do this? That is able to do this? Like,
I
there's
understand your question.
Okay.
I don't think I can answer that question now. My brain is
Okay,
turning on its own.
Okay, sir. Another thing, you said the error is showing that the male students, is this for grade or gender? Okay, gender. It's just between, it's out.
Why are you talking about the graph or the descriptive statistic?
The graph,
Okay. Let me plot the graph
but I'm
again.
not seeing it again.
Which of the graph?
The error stuff now.
Okay, the error stuff. No, I'm just trying. It tells us the you want to report your result, because now what we are using now is confidence bars. So it just tells us the lowest interval and the highest interval that the number of A's can fall in. So let me do it again. So have something like this.
Yes. So what I want to ask is, you said from this point to the upper point, that's the only. Yes, from there your arrow is now to the upper side. You said that's only where it can fall in, or I didn't get what you said there.
Okay, let me try again. So the error bars, look at it, is 95% confidence interval. So now let me use this to explain it. Let me use our case summary. Explore, sorry. Are you seeing the confidence interval here? So that's what it plotted. So it's the lower one is this, and the upper one is this, something like this. So now let me explain what we use this to do. Now in statistics, sometimes it's not proper to report just one value, because remember I started by explaining. Okay, you didn't join us then. In financial statistics, if you go to the hospital now, they will take a sample of your blood and run tests on it. But when they want to make conclusion, they will say this result is about all the blood in your body. But they didn't test all the blood, they just used a sample, right?
Yes, sir.
So it's statistical inference what this thing you'll be learning, they just take a sample, they play with it, do manipulations on it, but the conclusion will be about the entire population. Now, because of this, we are not using the entire population. It's possible that we may not be 100% correct. So because we may not be 100% correct, there's a possibility of errors. There are possibility of errors, or there's a possibility of an error in our results. So most time, if you report your value as an actual value, as a point estimate means just a single value. It may not be good. Because why? You didn't use every subject in the population. Rather, you considered what? A sample. So sometimes you have to make allowance for errors. That's what we are trying to say. You make allowance for errors. So that's why it's not too good to use point estimate. So instead of example, now if I want to look for the mean score of a student in the class, maybe I didn't use all the students in the class. The non-teaching student or non-academic student, we are not in school that day. So I only use the student that wrote the exam or that wrote the impromptu test. So it's better I use confidence interval to report it. And if I want to use confidence interval to report it, I can say the number of for scores now, example for scores. I can say in this class, the males are likely to score between 51 to 53. Do you understand?
Yes,
Rather
sir.
than saying that the males will score 52. That one is not too proper, because you will discover that if I report it as 52, there are some people that will score less than 52, and there are some people that will score more than 52. So I can report it as the males in this class are likely to score between 51 and 53. So it means this interval will contain the actual value that any student that is a male in that class will score. So any male in that class, any score will likely fall in this interval. So if you score 52, it will be there. If you score 53, it will be there. If you score 51.8, it will be there. So that's the meaning of confidence interval. So that graph is just trying to include your confidence interval in the chart. So that's all.
Okay, sir.
Any other question? But if you still need more explanation, we can, anytime you have any question, you can chat me on WhatsApp.
Okay, sir.
Okay. Then I will advise you to let me stop sharing. Let me stop recording.